Let's take a look at the answers for exam 1X. Question 1, the length in millimeters of the mesiodistal crown of the first molar of human fetuses can be approximated by L of t is equal to negative 0.01 t squared plus 0.788 t minus 7.048, where t is the number of weeks since conception. Question A, what is the length of the mesiodistal crown after 20 weeks? So here we want to compute L of 20, which would be negative 0.01 times 20 squared plus 0.788 times 20 minus 7.048, which is equal to 4.71 millimeters. Question B, when will the length of the mesiodistal crown be 2 millimeters? So here we're going to take the equation and set it equal to 2. Since we have a quadratic, we're going to move the 2 to the left side. That is going to combine with the constant term here, give us a 0 on the end. And then we'll use the quadratic formula to solve for t. So t is equal to negative 0.788 plus or minus the square root of 0.788 squared minus 4 times negative 0.01 times negative 9.048, all divided by 2 times negative 0.01. If you plug that in the calculator, you get 13.95 weeks and 64.85 weeks. And we're going to learn a little bit more about this situation in the next part, but it's going to reveal to us that this second answer is not valid. So we'll go ahead and mark that off for us. Question C, find the maximum length of the mesiodistal crown, and when does this maximum length occur? So we know that the maximum of a quadratic occurs at negative b over 2a. So this would be negative 0.788 divided by 2 times negative 0.01, which is 39.4 weeks. So that's when the maximum occurs. The actual maximum itself is found by taking 39.4 and plugging it into the equation, and you get 8.48 millimeters. And then the bonus question was explain why the maximum occurs at this time. Well, it's because human gestation is about 40 weeks long, so after this time period, then the baby comes out, and that's it. Okay. Question 2. The population of gray wolves in Wisconsin can be modeled by the function w of x is equal to 400 e to the 0.09x power, where x is the number of years since 2004. Question A. How many gray wolves were there in the year 2010? Well, 2010 as a year is 6 years in our model, so we need w of 6. 400 e to the 0.09 times 6. And if you work that out, you get 686 wolves. All right. Question B, assuming the wolf population continues to grow based on the model, in what year can we expect the population of gray wolves to exceed 12,000? All right. So we're just gonna set it equal. We're not gonna worry about the. Let's look at the answers for quiz 1Y. Here we have a graph, and part A says find the limit as x goes to 2 from the left. Here we have 12,000. Trace over the graph here, and as we get closer to x equals 2 from the left, we see that the y value goes to 1. Is divide by Part B, find the limit as x goes to 2 from the right. One trace from the right side as x goes to 2 from the right side. We see that we get down to -4. When the variable is in the exponent.
Part C, find the limit as x goes to 2,
the
full two-sided limit. Well, since the two one-sided limits are not the same, the full limit does not exist.
30 is equal to 0.09x. Because recall, if you have the natural log of e to something,
find the value of f of 2. That's where the function is defined.
In the exponent.
You look for the solid dot,
and finally,
where the function would be defined, and that is at 1. And part E, is f continuous at x equals 2?
We get
the answer is no,
79.
and that's because the limit
now this is the number
as
of
x
years
goes to 2 of f of x does not exist.
Take the base year of 2004 and add 37 to it.
Question 2.
So
suppose x goes to 5. The limit as x goes to 5 of f of x is equal to 7,
and we don't
and
round up
the function value f of 5 is equal to 9. What can you say about the limit as x goes to 5 from the right? And what can you say about the limit as x goes to 5 from the left? Well, since you have that the limit exists and is equal to 7, you know that both one-sided limits have to have that same value as well. If either of the one-sided limits was different than the other, then the limit would not exist.
So that's 1.
Notice that the fact that f of 5 is equal to 9 does not play a part in this question. Simply knowing that the function value at 5 is 9 is irrelevant.
The function continuous
in fact, the graph may look something like this. X is going to 5, the limit is going to 7, it may look something like that, and the function value itself is 9. So there's a solid dot at 5, 9, but there's certainly an open circle, a hole at 5, 7.
-2. The x minus 11 cancels.
Let's look at problem 3. Find the limit if it exists. So if you were to plug in x equals 7
plus 11 over 11 minus 2, which is 22 over
this one may actually work. Let's see.
In part B, let's go ahead and factor.
7
we have
squared
the limit as x goes to
-7
-5.
minus
The numerator
28.
factors is x squared
That would be
times
0
x plus 5.
over
The denominator
49
factors
plus
as
21
x plus
minus
5
28.
and x
The bottom
minus
is not
9.
going to be 0, it's going to be
Cancels
42.
the x plus 5.
So 0 divided by 42 is 42.
That gives me the limit as x goes to -5 of x squared over x minus 9.
So this one you did not need to factor and cancel.
So this is
it was
-5
going to work
squared
anyway.
over -5 minus 9.
Problem 4, find
25
the intervals
over
where the
negative
function g of x is equal to the square root of 15 minus 4x is continuous. So recall from our notes that a square root function is continuous everywhere that the inside function is greater than or equal to
Find the
0.
limit as x goes to infinity.
So we'll set 15
So
minus
we're going to
4x
divide
greater than or
each
equal
term
to
in the
0
numerator and the denominator
and solve for x.
by the highest power
So
of
move the
x
15 to the right side.
from the denominator.
We now have minus
highest power of
4x is
is
greater than
just
or equal
x
to
itself.
-15. Divide both sides
And we
by
simplify.
-4. And recall from algebra that when you
6
divide an
7
inequality
over
by a
x
negative, you need to switch the
over
inequality.
9 minus 13 over
So
x.
the continuous,
Now when
the
we take
function's
the
continuous
limit,
on
any
negative
term
infinity
that still has an x in
to
the
15
denominator
over 4
is going to go to
closed
0
at
as x goes to
15 over
infinity.
4.
So this results in 6 plus 0 over 9 minus 0, which is 6 over 9, which is 2/3. In question B, we'll do the same thing, but we need to acknowledge that the highest power in the denominator is x to the first. In the numerator, in order to get inside of the square root, I'm going to have to square that x. So inside, it's going to be dividing by x squared. On the outside of the square root, it's still just division by x. So here we have 16 plus 3 over x plus 29 over x squared over 8 plus 5 over x. And now anything with x in the denominator goes to 0. So this is the square root of 16 plus 0 plus 0 divided by 8 plus 0, which is the square root of 16 over 8, which is 4 over 8, which is 1/2. Question 6. Find the intervals where each function is continuous. In part A, that's a polynomial, so it is continuous from negative infinity to infinity. Question B, we have a rational function. So to find the points of discontinuity, we set the denominator equal to 0. And that factors is 3 and 7, minus and minus. So here x is equal to 3, x is equal to 7. If I draw out the number line, we have 3 and 7. These are bad points, but then we can shade in everything else. So we're going to have one interval here, second interval in the middle, third interval on the right side. And so the intervals of continuity are negative infinity to 3, union 3 to 7, union 7 to infinity. Notice that the numerator does not play a part in finding where a rational function is continuous. Question 7. Use the limit definition of derivative to compute this derivative. So f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x over h. Then we're going to plug in the function values evaluated first at x plus h. So that would be x plus h squared plus 4 times x plus h plus 13. Second, we have f of x, so that's x squared plus 4x plus 13 over h. Oops. H goes to 0. Now I'm going to expand x plus h squared, so that's x squared plus 2hx plus h squared. Next I distribute this 4, so it's 4x plus 4h. Finally I distribute this negative. We get negative x squared, negative 4x, negative 13 over h. Cancel the x squares, cancel the 4x's, cancel the 13's. And that leaves me with 2hx plus h squared plus 4h over h. Factor out the h. So we're going to get 2x plus h plus 4 divided by h. Cancel the h's. (2x plus h plus 4), and then evaluate the limit. So h goes to 0, and we get 2x plus 4. Question 8. The total amount of snow in inches that has fallen in a city is given by S of x is equal to 12x minus x squared for 0 less than or equal to x less than or equal to 6, where x is the number of hours since midnight. Find the average rate of change in the amount of snowfall between 1 a.m. and 2 a.m. So 1 a.m. is 1 hour since midnight, 2 a.m. is 2 hours since midnight. So we want the average rate of change from 1 to 2. So it's S of 2 minus S of 1 over 2 minus 1. If you plug those in, you get 20 minus 11 over 1, which is 9. Now we need the appropriate unit. It is an average rate of change. So it's the top unit, which is inches of snowfall, divided by the bottom unit, which is hours. So this is 9 inches per hour on average. Part B, at what rate is the snow falling at 4:30 a.m.? 4:30 a.m. is 4.5 hours since midnight. To find the rate, that means we need the derivative. So S prime of x is 12 minus 2x And then s prime of 4.5 would be 12 minus 2 times 4.5. And that's equal to 3. Again, it's a rate, so it's inches per hour. Question 9. Find the derivative of each. So f prime of x is equal to 56x to the 6th minus 20x to the 4th plus 9. Find the derivative of g. So first, we can't do the g yet. We need to rewrite it in fractional exponent form. So that's x to the 10 over 7 minus 5 times x to the negative 3. Now we can take the derivative. So we'll bring this down. So it's 10 over 7 times x to the 3 over 7 plus 15 times x to the negative 4. Then we rewrite this back in the appropriate form. So 10 over 7 times the 7th root of x cubed plus 15 over x to the 4th. Finally, we need to match these derivatives. And so it was d, c, e, b, and a. All right, thanks for watching.